All right, this is just the calculator section of the 4.1 to 4.3 review. I just wanted to do it with Desmos because my original key, I was using a graphing calculator. All right, so the first type of word problems we have are the arc length and angular speed, linear speed, that kind of thing if we're traveling on like a curved surface. And so the biggest thing to remember is this formula right here. You want to make sure you memorize this or memorize either this version or the rearranged version. I really don't know what's happening with my pen. So the way that we get radians, remember, it's the ratio between the arc length that theta opens into divided by the radius of the circle. You can also solve this for S. So honestly, I learned it first as arc length equals radius times theta. So I have this one in my head. You can have this one in your head. It really does not matter. But we do use arc length over time for speed. So that would be arc length is S. So that would be R times theta over whatever time they give you. Angular speed is radians. So that would be theta over whatever time they give you. All right, so theta has to be in radians. If you're given theta in degrees, you convert it to radians first, and then you carry on. So use the radian formula to solve each problem. You're allowed to use a calculator. A car's wheels have a diameter of 28 inches. I like to label stuff out as I go and say which pieces I am looking for. So that tells me, a diameter tells me about a radius. The radius then is 14 inches. How far, S, will the car travel if the wheels revolve 10,000 times? That doesn't mean that we have 10,000 radians. It means that theta is 10,000 full circles. 10,000 times 2 pi. So theta is 20,000 pi. Give the distance traveled first in inches and then in miles. So what I'm going to do is, and this is radians, so remember radians don't really have a unit. It's just a ratio between two numbers. So there are no units on this. So we have how far S will the car travel? So S is equal to 14 inches times theta, R times theta, 20,000 pi. And this is first going to be in inches. So let's see what this comes out to. Let's see. Get my screen split here onto Desmos. All right, so 14 times 20,000. Don't put a comma in. You can type the letters pi for pi. This is in inches, so let's go ahead and write this down. Sorry, I'm having technical issues here. Doop, doop. Okay, so this is 879,645.943 inches. That's how far it traveled in inches. How do I convert that to miles? Well, I take this number and I take this number. Golly. Let me use my keyboard here. I take this number and oh my gosh. And I try not to let everything glitch. All right, let me get that number on there again. 14 times 20,000 pi. Okay, boom. This answer, copy, paste. That's in inches. If I divide it by 12, this is how many feet I have. If I divide that answer by how many feet are in a mile, 5,280, I get how many miles we've traveled. So 13.833. Could I have done this, divide by 12 and divide by 5,280? Yes, I could. Get the same answer. And did I have to use this, or could I have said 14 times 20,000 pi? Sure, could have done that too. All right, so 13.883 miles. I'm really having technical issues here. There we go. 13.883 miles. And that was this answer divided by 12 and then divided by 5,280. All right, for my next problem. How many radians, find theta, will a car wheel of diameter 30 inches, so R is 15 inches. How many radians will a car of diameter 30 inches make as the car travels a distance of 1 mile? Distance is always arc length, but we can't have miles and inches together. So 1 mile is 5,280 feet. Multiply that by 12. 5,280 times 12. 63,360 inches. I wouldn't want to convert 15 inches to miles because that would be a decimal with a lot of decimal places, and I don't want to do that. I almost wrote feet, meant to write inches. All right. So what were we trying to solve here then? So let's see. How many revolutions will the car wheel make? So let's figure out theta, and then let's figure out how many revolutions that is. So remember, theta is equal to arc length over radius. And now that I have them in the same measurement, I can just divide these two numbers. So this will tell me how many radians theta is. Oh, goodness. Okay. All right. So 6,360. Gosh. 63,360 divided by 15 is 4,224 radians. And theta is in radians because remember, this is the radian formula. So that's how you get theta in radians. How do I figure out revolutions? Well, remember, one revolution equals 2 pi. So if you divide the number of radians by 2 pi, then you're going to get how many revolutions. So 4,224 divided by 2 pi is 35. Oh, wait, not divided. Sorry. If you multiply it by 2 pi, you're going to see how many, or no, wait, yeah. If we divide by, hold on, let's see. Revolutions times 2 pi gets you radians. Yeah. So radians divided by 2 pi. That's right. Gives me my answer. So let me get this up again. 672.270 revolutions. Sorry about that. And if you get confused, like I was turning myself in circles there, I looked back at the previous problem and said, all right, now what did I do? When I was given revolutions, I multiplied by 2 pi to get radians. So if I have radians, I would divide by 2 pi to get revolutions. All right, what is this problem? The Greek mathematician, I probably should know how to say his name, I'm going to mess that up. I'm sorry. I'll have to YouTube this and check it and fix it in class. Anyway, he measured the circumference of the Earth from the following observations. He noticed that on a certain day, the sun shone directly down a deep well in Syene. Ooh, I really should have looked this up. Sorry, guys. At the same time, in Alexandria, 500 miles north, on the same meridian, the rays of the sun shone at an angle of 7.2 degrees to the zenith. So, okay, this is hard to see right here, but see how there's this little line right here that this is being measured from? That is parallel to this line here. So if this is 7.2, so is this little angle right there. That seems important. 500 miles is an arc length, because it's this curved distance on the Earth. Use this information and the figure below to find the radius and the circumference of the Earth. So the radius would just be, right here from the center here to this value. We have an arc length, we have a theta, we can find a radius. But remember, theta must be in radians. So theta is 7.2 degrees. We have to multiply it by pi over 180 to get it into radians. Okay, and then what is our formula? Arc length is equal to radius times theta. I want the radius, so arc length divided by theta will be my radius. So the arc length is 500. Theta is whatever 7.2 pi over 180 is. And so r will come out to approximately, let's see, 500 divided by 7.2 pi divided by 180. So that's coming out to 3,978. Write this down. 0.874 miles. That's the approximation for the radius of the Earth. It also said find the circumference of the Earth. So what's the circumference formula for a circle? Circumference is 2 pi r. So I'm just going to take this answer and multiply it by 2 pi. Now, I could just say this. I kind of like doing this. I don't know if this is going to work. Oh, yeah. So I highlighted it and hit parentheses, and it did that. Let's just say times 2 pi. Or you could copy that answer down there. And this is pretty cool, right? It came out to an exact number. So that's 25,000. Yep. 25,000. That would still be measured in miles for the circumference of the Earth. All right. And just fun fact, the actual radius of the Earth is 3,958.8 miles. I mean, that's pretty close. This is 276 to 195 BC or BCE. I mean, that's pretty amazing that they could get that accurate without all the technology that we have, just with straight up math. Okay. To measure the speed of a current, scientists place a paddle wheel in the stream and observe the rate at which it rotates. If the paddle wheel has a radius of 0.2 meters and rotates 100 RPMs, that's revolutions per minute, find the linear speed of the current in meters per second. All right, so let's take a look here. We were given a radius. We were given something we can use for theta. Theta is 100 times 2 pi. It's always revolutions times 2 pi. And this is happening in a time, which is 1 minute. But we need everything to be in seconds, so let's change that to 60 seconds. The linear speed formula is just arc length over time. And arc length is just radius times theta over time. So 0.2 times, let's just call that 200 pi, divided by 60 seconds is going to give us our speed in meters per second. All right, so 0.2 times 200 pi divided by 60 comes out to 2.094. And that's already measured in meters per second. If you want more practice on this arc length, linear speed, angular speed stuff, I made a worksheet that's optional. And I'll have a video for this if I don't already. But it's got practice, just kind of like going through these different types of problems. Okay, what are the other types of calculator problems? It's the right triangle trig stuff. So let me skip past the non-calc part. All right, so for these problems, show the trig equation, solve with 3 decimal point accuracy. You've got to write some stuff down, even if you're ending up solving by graphing later on. So the angle of depression from the top of a tower to a point 300 feet away from the base of the tower on level ground is 63 degrees. Find the height of the tower. Where do you start? You start by drawing a right triangle. Angle of depression is actually also an angle of elevation, which is always drawn from the horizontal to the hypotenuse. So 63. Almost wrote it backwards. This is the angle from a point 300 feet away from the base of the tower. So a point on the ground to the bottom of the tower is 300 feet. Find the height of the tower. I'm going to call that y. I have opposite and adjacent, so I need to use tangent of the angle equals opposite over adjacent. To solve for y, it would just be 300 times the tangent of 63 equals y. So let's approximate that. 300 times the tangent. By the way, I need to be in degrees, which I am. I'll remind you of this on quiz or test day. You should be in degree mode. When you take the AP test, the application you're using will be in radian mode by default, which it should be. You'll only need radians on our AP exam. Okay, so my answer is 588.783. And that is feet. All right, for the next one. The top row of the red seats behind home plate at the old Cincinnati Riverfront Stadium was 90 feet above the level of the playing field. The angle of depression, also elevation, to the base of the left field wall was 14 degrees. How far was the base of the left field wall from a point on level ground directly below the top row? Give yourself a right triangle. An angle of depression should be drawn as an angle of elevation, 14 degrees. 90 feet above the level of playing field, so 90 feet vertically. How far was the base of left field to a point directly below the top row? So let's find x. We have opposite and adjacent again. So let's use tangent of 14 degrees equals 90 over x. X is equal to 90. You'll end up multiplying x over here and dividing by the tangent of 14 degrees. And then I type that in. So 90 divided by a tangent of 14. And I'm getting that x is approximately 360.970 feet. All right, number 40, civil engineering. The angle of elevation from an observer to the bottom edge of the Delaware River drawbridge observation deck, located 200 feet from the observer, is 30 degrees. The angle of elevation from the observer to the top of the observation deck is 40 degrees. What is the height of the observation deck? It's a little hard to see in this picture, so I'm going to draw it out here. There are two triangles happening. There's one where the inner angle here is 30 degrees. And then there's one where this whole angle is 40 degrees. And we know that this horizontal distance is 200 feet. We don't know the vertical distance of this little leg from here to here. And we also don't know this distance, but I don't want to call this little section y, because remember, you have two right triangles here. Let's see if I can draw that a bit better. There we go. So I want each leg to be x and y, and then what is my answer going to be? What is the height of the observation deck? So that means what they mean is what is this distance right here, from here to here? So that would be y minus x. So let's get some equations set up. It doesn't matter where you start here. I'm going to start with a smaller triangle. So the tangent of 30 degrees is equal to x over 200. I'm using tangent because we have opposite and adjacent. And then the tangent of 40 degrees is equal to y over 200. And I can solve each of these for x and y by multiplying the 200 over to the opposite side of the equation. And remember, the height of the observation deck just means from the bottom of the deck to the top roof there. So that's y minus x. And we'll just type this in and see what it comes out to. So that's 200 times the tangent of, not 30, let's see, y was 40. So 200 times the tangent of 40 minus 200 times the tangent of 30. Yeah, so I'm getting 52 points. That would round to 350. Measure that in feet. All right. For this problem, golly, we had a problem like this, a couple problems like this, where we had two things on the same side of a plane or hot air balloon. I forget what it was. From the top of a 100-foot building, a man observes a car moving toward him. If the angle of depression of the car changes from 15 degrees to 33 degrees during the period of observation, how far does the car travel? All right, so for this one, oh, wait a minute. Why do I have a different problem? Do I have a different problem on yours? I do. Sorry. Let me see if I have it here. I was just looking at my paper answer key. Oh, okay. How about this? Let me just erase this one here then. Okay, so this is one of those that has a couple of different unknowns. Not sure why I cut that other problem, but whatever. Okay. In traveling across flat land, you notice a mountain directly in front of you. Its angle of elevation is 3.5 degrees. They've got that marked off already. After you drive 13 miles closer to the mountain, the angle of elevation is now 9. We don't know how tall the mountain is. We're trying to find that out. Let's call that y. We don't know how far this point is from the base of the mountain. Let's call that x. That means that this distance, this leg of this triangle, would be x plus 13. Because we have opposite and adjacent, we're going to set up two tangent equations. Remember, we can solve by graphing pretty quickly here, or I will also go through the algebra. So one equation would be the tangent of 3.5 degrees equals y over x plus 13. The other equation, the smaller triangle, would be the tangent of 9 degrees equals y over x. You can solve by graphing right now. Desmos. Type these two equations in and see where they cross. If something is not working for you when you're doing that, whether the numbers are weird or you typed something in wrong or whatever, and you're just not able to find the issue, I will show you how to solve these algebraically as well. So here's the first equation. In a second line, I'm typing the second equation, which was tangent of 9 equals y over x. And I want to double check that I'm in degree mode. I am, degrees right there. And then just where do these cross? So right there, apparently. What do I want? Which answer do I want? I want the y. Remember it said how high is the mountain? Is that what it said? Yeah, approximate the height of the mountain. So y is approximately 1.295 miles high. What if you can't get this to work or something's going wrong or whatever? You can also solve algebraically. So you could say x plus 13 times tangent of 3.5 equals y, and x times tangent of 9 equals y. You could graph those two lines and find their intersection point, but I think if you're going to graph, you would do it from the original. So maybe you set these two equations equal to each other. X times the tangent of 3.5 plus 13 times the tangent of 3.5. That equation has to equal x times the tangent of 9. Put the x's on the same side by subtracting this one over. Subtract your non-x over to the other side. Factor an x out. That's why you get them on the same side. And then solve for x. Now you have to be careful for this because x is not the final answer. let me write this down first. I'm going to get an answer for x, but remember, we want y. Well, back here, we have two equations to find y. Y is x times tangent of 9. So y will come out to 1.295. But let me do this math to double check. Okay, so I'm going to carefully type in negative 13 times the tangent of 3.5 divided by tangent of 3.5 minus tangent of 9. This is my answer for x. I want to take this answer, copy, paste, and I want to multiply it by the tangent of 9 degrees, and I get, 1.295. So I do get the same answer. An alternative would have been solve both of these equations for x so that your variable is y, and then you do get the answer for y right away. I prefer that you just solve by graphing. That's what I want you to do on the AP test. It's what I want you to do next year in calculus. But I don't know, maybe they give us a non-calculator problem where they have the answers in this form, and we need to know how to do that. Also, sometimes technology is not your friend, and algebra is. All right, that finishes the calculator part for Desmos. Hopefully you've had lots of practice with this through the homework and stuff. But come in and see me if you need more help.